talk about one of the applications of the Pythagorean theorem, and there are many applications, but this is just one. So if I were to give you a coordinate system like this and has a little line segment plotted on there, and I asked you how long is that line segment? Well, on a line like this, it would be easy because you could just count the squares that it spans, and so that would be 4. But if the line segment is on a slant like this, it would be more difficult because it kind of cuts across the middle of several different squares, and you don't know exactly how long it is, so it's going to be a little tougher to do that. But we're going to show you a process where you can just draw a right triangle and then treat this as a Pythagorean theorem problem. So let's take a couple of notes first. So using the Pythagorean theorem to find the distance between any 2 points on a coordinate system goes as follows. First, connect the endpoints in a right angle to create a right triangle. 2, count and label the length of the legs. And 3, use the Pythagorean theorem to find the distance or the length of the hypotenuse. So here's our first example. We have a slanted line. In fact, this was the one we saw a moment ago. So I would, using a marker or pencil, just use a couple of straight line segments and make a right triangle out of this with that side that we're trying to find the length of as our hypotenuse. Now we look at our triangle, we actually have a length of 3 on this side and 2 on this side. So using the Pythagorean theorem, we can say a squared plus b squared equals c over here squared. And 3 squared is 9, 2 squared is 4, and all of that equals c squared. So now when I combine 9 and 4 together, I get 13 equals c squared. So to find c, I have to take the square root of both sides of my equation. And so I end up with c equals the square root of 13, which is your answer if you just leave it in radical form. If you actually find the square root of that, which I will now do with my calculator, you do 13 square root, and we round it to the nearest tenth, so it's going to be 3.6. So when you're doing your worksheet today, we want you to write both answers. First, the radical form, and then second, the decimal form simplified to the tenths column. All right, on our next one, we'll make our triangle, our right triangle, by creating 2 little line segments. This right triangle has a base of 1 and a side length of 1, 2, 3, 4. So when I use the Pythagorean theorem, I'm going to have 4 squared plus 1 squared equals c squared. Okay, so 4 squared. So now to do this problem, we have 4 squared equals 16, and 1 squared equals 1, and all of that equals c squared. So 16 plus 1 is 17, which equals c squared. And then to find c by itself, I do a square root of each side. So c equals the square root of 17. That's my radical version of the answer. And then when I do the square root of it, I do the 17 square root, and I get 4.1 when I round it to the nearest tenth. So 4.1 is my answer when I round it to the nearest tenth. the square root of 17 is my radical form of the answer. Okay, keep it working. On our next one, we've got a base of 2 and a side length going up and down like this. 1, 2, 3, 4, 5, 6, so that's 6. So a squared would be 6 squared. B squared would be 2 squared. And now all of that squared and added together equals c squared. So we know that 6 squared is 36. B squared, or 2 squared, is 4. And all of that equals c squared. And 36 plus 4 is 40. All right, so now I just have to take the square root of both sides. And that gives me c equals the square root of 40 for my radical version of the answer. But then when I do that actual square root of 40, I end up with 6.3 for my decimal version of the answer. So here's both the answers that we will be looking for on your worksheet. All right, moving along, we've got a little longer line segment, and it's not even connected together. So in this one, we actually have to do the work of connecting these two dots together. And then now we'll make the right triangle by making the base and the height. 1, 2, 3, 4, 5 for our height. And for our base, 1, 2, 3, 4. So we know from the Pythagorean theorem that a squared plus b squared equals c squared. Yeah, I should have put 5 squared, and this is c, right? I almost put a 6 there. So we got 25 plus 16 equals c squared. 25 plus 16 is 36, 37, 39, 41. And now we're just going to do the square root of both sides to find the radical and the decimal version of this answer. So c equals the square root of 41, or square root of 41, and I do that on my own calculator, equals 6.4 when I round it to the nearest tenth. So 6.4. All right, I'm thinking this doesn't look too bad. All right, now what if we, well, again, if we give you the two dots, but we don't actually connect them? In that case, you actually have to connect the dots. So in most cases on your worksheet, you shouldn't need a line tool. You shouldn't need a ruler or a line tool. But in this particular case, probably be helpful because they're far enough apart. So we do our base. Now we do our height. And our base in this case is 7. And our height, hold on, let's just look. I meant to say 8, sorry. 8 across on the bottom and 8 up on the side. So our Pythagorean theorem is going to look like this. 8 squared plus 8 squared equals c squared, or 64 plus 64 equals c squared. And then we take the square root of both sides. We get the square root of 128 equals c. And then we do the square root of 128 using our calculator. 128 square root, and we get 11.31. So C equals 11.3. Okay, so 11.3 for C on that one. Keep it going. Okay, now as we get closer to the end here, notice that we're giving you less and less information. So in this case, we actually have to graph the 2 points. So 0, 2 would start out right there. Then 7, 7 would be about right there. So then we connect our dots. Oh, that's not very good. We can do better than that. Let's connect those dots. Let's go ahead and use the line tool. So here's our hypotenuse. And then to find the other part, we make this right triangle with our right angle right there. And then up the right side, we have 1, 2, 3, 4, 5. And across the bottom, we have 1, 2, 3, 4, 5, 6, 7. So a squared, 5 squared, plus 7 squared equals c squared. So we have 25 plus 49, and that gives us a total of 74. And all of that equals c squared. So to find what I'm looking for, I have to do the square root again. So square root of 74 equals c. And then when I do the square root of 74 on my calculator, I get 8.6. So c equals 8.6. So up here in our hypotenuse, we have 8.6. Okay, for our next one, we actually have to plot these points. So -6 and 1, right there, and then -4 and 5, -4 and 1, 2, 3, 4, 5, right there. So we draw our diagonal, which is going to be our hypotenuse. Then we complete the triangle and fill in the length of the sides. So 2 and 1, 2, 3, 4. So a squared, 4 squared plus 2 squared equals c squared. So 16 plus 4 equals c squared. And 16 plus 4 is just 20. So when we do the square root of both sides, we get c equals the square root of 20, which when we do that on our calculator, ends up being 4.5. 4.5 when you round it to the nearest tenth. Okay, so we've got this last example, then we'll get on to our assignment. So the first point is at -7, -7. Put it down here in the lower left-hand corner. Then we have 4 and -1, 2, 3. So we've got to draw a line for the hypotenuse. And then we can find the base of our triangle and the side of our triangle. And the side is 1, 2, 3, 4 units long. Our base is 11 units long. So we have 4 squared plus 11 squared equals c squared. And if I take the square root of both sides, we end up with c equals Well, first of all, we got to put it in radical form. So 16 plus 121, 16 plus 121, which would be 137. So the square root of 137, and then to put it in decimal form, 137 square root comes out to be 11.7. So that's how you do these kind of problems. It should be pretty straightforward. Maybe you've seen them before, but we're going to give you a worksheet, and we want you to round your answers to the nearest tenth place. Thank you very much.